Welcome to NetwalaBhaiya, and today is our Climatology Lecture 3 for Paper 2 Geography UGC NET GRF. And here, while we study with emotions, we'll be making sure that your NET GRF journey becomes easy and achievable. So, I'm Arithra Mandal, and today we'll be starting off with the unit Climatology, that is Unit 2, and this is our Lecture 3, okay? It is about the pressure belts and winds. Previously, we have discussed about insolation, heat budget and temperature, and I would like to suggest that you make sure that you watch those videos because everything in geography is interconnected to each other. सब कुछ एक साथ interlinked है, interconnected है. इसकी वजह से if you do not understand the concepts that are there previously, such as of temperature, as how temperature is distributed, how temperature is dynamically distributed, what is the thermal distribution of temperature and everything, until and unless you don't understand those things, it will be very difficult to understand pressure belts and winds. So let's move on without any delay. So before that, this is our Telegram channel. Make sure to join it for all written notes as well as notes from my side and notes which I myself have prepared during my GRF journey. And the most beautiful thing for it is it's for free. So make sure you utilize it and tell all of your friends and those who are preparing for it for UGC NET GRF to come follow us, join us. And these are our social media handles: YouTube, Instagram, Facebook. And to connect with us better, you can also call us on this number or text us on WhatsApp. Okay, so the other courses that are available, Amit sir is already taking for paper 1, so make sure to follow paper 1 classes also. And if there are students who are in your vicinity or in your friends who are from UGC NET Commerce, they can also follow this channel. Fine. So what is the agenda of the class? We should always have a plan as to what we do. Even during your UGC NET GRF journey, you should always have a plan as to how you will study, as to what you will study after what, right? So there should be a step-by-step progression of things. There should be a proper structure, and the structure of the class today, the agenda of the class today is that we will be discussing about the global atmospheric circulation cells, the circulation cells that are present in the atmosphere. जितने भी cells present हैं उसके बारे में discuss करेंगे. Pressure patterns, high pressure, low pressure के क्या क्या patterns रहते हैं, what are the pressure patterns across the surface of the earth, and the thermal and dynamic pressure belts that are there, what are the different pressure belts that are being formed, the seasonal pressure belt systems. These are very important when it comes to MCQs, okay? So, and then the factors or the forces that affect the wind, the pressure gradient force, Coriolis force, friction force, and global wind systems as well. There is one more topic, that is local wind systems, that we talk about. Local wind systems is something that we do not need to explain in a very detailed manner. उतना ज़्यादा detailed manner में explain करने का ज़रूरत नहीं पड़ता है. That is why we will be making sure that we provide you a good, proper, solid list of local winds that is there flowing across the earth on different places. And for that, you will have to make sure to join our Telegram channel for it. Okay, fine. Now let's move on. The first topic that is there, the global atmospheric circulation cells. Okay, so let's draw this first. In geography, it is very essential that you draw your diagrams. Okay, so this is the earth, half of it. We are going to take half of it, okay, to understand it better. And जो भी हम यहाँ पे बता रहे हैं, ये northern hemisphere के लिए है, but this also is applicable to the southern hemisphere. Okay, for now let's understand it as the northern hemisphere, and it will be the same in the southern hemisphere as well. Fine. So this is about 30 degrees north. This is your 0 degree equator that is there. Then we have the 60 degrees north, that is the Arctic Circle, the 66.5 to be more precise. And here is your North Pole. Okay, so now we have 3 cells that are working here. 3 cells that are working here, and the first cell that we have working is called the Hadley cell. It is called the Hadley cell. Next we have the Ferrel cell. Next we have the Ferrel cell, and finally we have the polar cell. Okay, we have the polar cell. Fine. So let us try to understand the cells in proper understanding, okay, as to what they mean. इनका meaning क्या है, इनका origin कैसे हो रहा है, ठीक है? All these details that we need to understand of this Hadley cell, Ferrel cell and polar cell, what these are, what kind of questions might be asked, what are the factual MCQ bullet points that you need to know for each of these cells. So let's discuss about that first. So यहाँ actually हो क्या रहा है? These are atmospheric circulations. I mean that when the air for example, if there is air in this place, this air is coming towards the equator, getting up, again flowing back, and again settling. Okay, so there is a circulation, there is a whole circulation pattern that is going on, and this is the different cells that are there. So first, let's discuss about the Hadley cell that we saw right now. Hadley cell is also called as the K2 cell. This is a different name for it. So questions might be asked as to which of the following cells is also known as the K2 cells. Okay, so it is the Hadley cell. Hadley cell is also known as the K2 cell, and its extension is from 0 degree to 30 degrees north, or from 0 degrees to 30 degrees south as well. Fine. So what happens here? Equator ke paas at 0 degrees, at 0 degree equator, and this is for example our 30 degree north. At equator, there is a lot of heat. This is why you need to understand the temperature patterns that we have studied in the previous class. So make sure that you follow that. Okay. So at the equator, there is a lot of heat, because of which what will happen, that the air will rise. हवा गर्म होगा, हवा ऊपर की तरफ उठेगा, वो हल्का होते हुए जाता है, फैलते हुए जाता है, and it goes up. Okay. Now when it goes up, it needs some place to settle. So either it will go this side or it will either go that side, isn't it? And it will go this side and it will settle down here at the 30 degrees north. So यहाँ पे the amount of air is less now, and here the amount of air is more now. There is high pressure here, there is low pressure here. Now air or wind moves from high pressure to low pressure, because for example, if there is air that is there at this place, बहुत ज़्यादा high pressure है यहाँ पे, और यहाँ पे low pressure है completely, so the wind will be compressed here and it will move towards the low pressure. Okay, it will move towards the low pressure. So what will be the direction of the wind? The wind will move from this 30 degree north towards the 0 degree equator, and it will complete a whole circle. It will complete a whole cell, which is called as the Hadley cell. Okay, so that is what we need to understand. And these surface winds that we are seeing right here below, this is also called as the trade winds, isn't it? These are also called as the trade winds. And we have to understand that because there is a role of temperature in the formation of this cell, इस cell के बनने में, formation में, there is a role of temperature in it. That is why it is also called as the thermal cells. Okay. Next, let us, to understand the Ferrel cell, we need to understand the polar cell first. Okay. क्योंकि Ferrel cell जो है, Ferrel cell is like a sandwich. It's like Hadley cell एक bread है, Ferrel cell एक ऊपर में एक और, polar cell ऊपर में एक और bread है, and this Ferrel cell is in between. It's like a sandwich in between. Okay, so to understand the Ferrel cell, because Ferrel cell का origination जो होता है, Ferrel cell का जो creation होता है, that is because this polar cell and this Hadley cell exist. The Ferrel cell would not exist if the polar cell or the Hadley cell did not exist. Okay, so we need to understand that. Okay, now the polar cell में क्या हो रहा है यहाँ पे? There is 90 degrees north here. This is the pole, and this is your 60 degrees north. Okay, so what is happening here, that at the poles there is, because it is very cold and बहुत ज़्यादा ठंडा होने की वजह से there is high pressure. Okay, this is why you have to understand the relation between temperature and pressure, because when there is high temperature, pressure is less. When there is low temperature, pressure is high. So since in the polar areas there is low temperature, बहुत ज़्यादा ठंडा होता है, यहाँ बहुत ज़्यादा high pressure है, तो definitely the air will move out from this high pressure towards these places. Okay, it will move out, and when it is moving out, because of the air masses and fronts that we'll be talking about later in other videos, in the next videos that will be coming up, in the next lecture that will be coming up, we'll be talking about air masses, fronts and all these. तो यहाँ पे air masses and fronts के formation की वजह से near 60 degrees, what happens is that this air gets uplifted, and again it goes thrown back here again. ठीक है? So again this circle is formed, and this is called as the polar cell. Now since this polar cell is existing here, the Hadley cell is existing here, in between we have the what we known as the Ferrel cell. Okay, so this polar cell is also thermally induced, because it is starting because of a thermal reason, that polar areas में बहुत ज़्यादा ठंडा है, टेम्परेचर के वजह से, थर्मल रीजन का मतलब है टेम्परेचर की वजह से स्टार्ट हो रहा है. ठीक है, सो सिंस इट इज स्टार्टिंग बिकॉज ऑफ अ रीजन ऑफ टेम्परेचर, इट इज कॉल्ड अ थर्मल ड्रिवन सेल. एंड since this Ferrel cell, there is nothing like that कि temperature की वजह से बन रहा है, there is no role of temperature to play, it is only existing because the polar cell and the Hadley cell exist. That is why this Ferrel cell is called as the dynamic cell also. It's also called as the dynamic process. So it is an indirect cell. और Ferrel cell में जो winds move करते हैं on the surface, these are called the Westerlies, and on the polar cells the winds that move on the surface is called as the Easterlies. Okay, so that is what we all need to know about the the atmospheric air circulations. Okay, this is the general pattern of circulation of air. Fine. Now let's understand the pressure pattern. Okay, pressure pattern. First of all, again I like to repeat this thing that टेम्परेचर इफ इट इंक्रीजेस, अगर गर्मी बहुत ज्यादा आपको लगेगा तो आप क्या करेंगे, आप फैलेंगे, आप आराम से रिलैक्स होकर रहने की कोशिश करेंगे. यू विल नॉट ट्राई टू बी लाइक वेरी कॉन्ट्रैक्टेड, बहुत ज्यादा ठंडा लग रहा है, वैसे नहीं. ठंडा लगने से हम लोग क्या करते हैं, बहुत ज्यादा जम जाते हैं, कॉन्ट्रैक्ट हो जाते हैं, छोटा हो जाता है, ठीक है, कंप्रेस हो जाता है. तो जब गर्मी बहुत ज्यादा रहेगा तो प्रेशर क्या होगा, प्रेशर कम हो जाएगा, ठीक है, बिकॉज यू आर नॉट कॉम्पैक्टिंग योरसेल्फ. And if the temperature is less, देखिए एरो नीचे की तरफ है, ठीक है, it means temperature is less. And when you're making notes, you need to focus on these kind of techniques of making notes. क्योंकि आप कितना बार लिखेंगे कि temperature, if temperature is high, pressure will decrease. No, all you need to do is write a T and put a arrow beside it, and that makes your notes, isn't it? So temperature, if it increases, pressure decreases, and temperature, if it is less, then pressure increases, because then all the air is getting compact and compressed and condensed. Okay, that is why the pressure is increasing, because एक ही जगह में there is a lot of air. Okay, and air has some weight, air का कुछ वजन है, और इस वजन वो क्या कर रहा है, वो दबाव डाल रहा है on the surface. It is causing a pressure on the surface, it is putting its weight on the surface, isn't it? And that is what is pressure that we are talking about. High pressure, low pressure, जो भी concepts होते हैं, this is what we are talking about actually. Okay, this pressure, ये दबाव के बारे में बात कर रहा है. और at sea level अगर हम लोग देखते हैं तो millibars, we are measuring it in as millibars. Okay, this is called millibars. Okay, millibars. इसके लिए आपका एक डिवाइस रहता है जिसे हम लोग बोलते हैं हाइग्रोमीटर, and in that we fill in mercury, a lot of mercury. Okay, what do we fill in? Mercury is a liquid metal that we need to understand. And what happens that there is a tube like this. Okay, there is a tube like this. Now when air will exert its pressure, यहाँ पे इसके आसपास में एयर है, ठीक है, एयर विल एक्सर्ट इट्स प्रेशर, एंड क्या करेगा, ये पुश करेगा मरकरी को कि तुम इस ट्यूब के अंदर में जाओ, ठीक है. इट विल रेज अप दिस मरकरी, और मरकरी इस ट्यूब के अंदर राइज करने लगेगा विद द एयर प्रेशर. तो जितना ज्यादा मरकरी राइज करता है इस ट्यूब के अंदर में, दैट इज व्हाट वी आर मेजरिंग इट एज मिलीबार्स. इसका जो मेजरमेंट पैटर्न है, ये जो मेजरमेंट हम लोग करते हैं, ये मेजरमेंट इज इन millibars. Okay, and what is the normal pressure that we are talking about? We are talking about 1013.25 millibars is the normal pressure that exists. इससे ज्यादा अगर होता है तो then we call it as higher pressure. If it's lower than this, it is low pressure. Okay, that's how it is. And at about 5.5 kilometers, अगर आप 5.5 किलोमीटर अगर आप ऊपर की तरफ जाते हैं in the atmosphere, if you go higher in the atmosphere, the pressure decreases again. If you go for example the altitude, if your height is increasing, the pressure will decrease. क्यों? Why? Because when you are going higher, the amount of air that is there, पहले हम लोग एटमोस्फियर के कॉन्सेप्ट्स के बारे में जब हम लोग पढ़ रहे थे कि 90% ऑफ द एटमोस्फियर इज कंप्रेस्ड विद इन ओनली 16 किलोमीटर्स फ्रॉम द सरफेस, है ना. बस सरफेस से सिर्फ 16 किलोमीटर के अंदर में 90% ऑफ द एटमोस्फियर्स मास इज प्रेजेंट. उसका वजन ऑलरेडी 90% इसी में प्रेजेंट है, और एटमोस्फियर इज अबाउट थाउजेंड्स एंड थाउजेंड्स ऑफ किलोमीटर वाइड, है ना, लेकिन 90% उसका 16 किलोमीटर के अंदर ही है, isn't it? So आप जितना ज्यादा ऊपर की तरफ जाते हैं, what happens is that the air becomes thinner and thinner. एयर का अपना वजन ही कम हो जाता है, तो वो दबाव डालेगा कैसे? How will it exert pressure? Isn't it? How will it exert pressure if its own weight is increasing, if its own weight is decreasing? So when you go up 5.5 kilometers, what happens? The pressure drops to only 500 millibars. हाफ हो जाता है प्रेशर. इसीलिए हम लोग को ब्रीदिंग प्रॉब्लम्स होते हैं, बहुत सारा किसी को नोज ब्लीड होता है when we go up in high mountains, and as we go 10 kilometers up into the troposphere, the pressure becomes only 250 millibars. The pressure is extremely low here. Okay, so pressure falls very drastically with the decrease in the air density because of the increase in altitude. Now व्हाट इज दिस सरफेस पैटर्न? अब सरफेस पे कुछ अलग पैटर्न है, ठीक है। प्रेशर का पैटर्न वर्टिकली क्या था? सी, वर्टिकली इज दिस कि आप ऊपर जा रहे हैं तो आपका प्रेशर डिक्रीज कर रहा है, लेकिन सरफेस पे, जमीन पे, हॉरिजॉन्टली, दिस इज हॉरिजॉन्टल, ठीक है, एंड दिस इज वर्टिकल। ओके, वर्टिकल मतलब ऊपर जा रहे हैं आप, तो वर्टिकल आपका प्रेशर हम लोग समझें कि अगर आप ऊपर जा रहे हैं तो प्रेशर घटेगा, लेकिन सरफेस पे क्या सिचुएशन है, सरफेस पे क्या कंडीशंस है, दैट वी नीड टू अंडरस्टैंड। ओके, सो let us draw the pressure belts itself. Why discuss and look at notes so much? Let's draw it. We are students of geography, and always maps and diagrams are our weapons. I would always say that. Okay, so let's draw the pressure belts. This is your beautiful earth that is not very circular right here, and isme there is this equator that we have, the 0 degree. Then we have the 30 डिग्री, ये क्या हो जाएगा, 30 डिग्री साउथ। यूजुअली सब कोई सदर्न पार्ट को बहुत ज़्यादा नेग्लेक्ट कर देते हैं, बट वी विल बी कनेक्टिंग विद इट बेटर एंड वी आर ड्राइंग द सदर्न पार्ट फर्स्ट। देन वी हैव द 60 डिग्रीज साउथ एंड वी हैव द 90 डिग्रीज साउथ। दिस इज योर सदर्न हेमिस्फीयर। नाउ वी हैव द 30 डिग्रीज north, we have the 30 degrees north, we have a 60 degrees north latitude, and finally what is it, 90 degrees north latitude, that is your north pole. So इस अर्थ के ऊपर क्योंकि यहाँ अलग अलग प्रेशर सिस्टम, अलग अलग टेम्परेचर सिस्टम्स है, कहीं पे बहुत ज्यादा गर्मी रहता है, फॉर एग्जांपल इक्वेटर पे, here the temperature is very high, okay, in the poles the temperature is very low. Again in this place there will be like various factors are there that we need to understand and we need to study. Okay, we'll be explaining it as we move on through this diagram. So first of all, let's draw these things. Let's take high pressure as this red color. This is your high pressure belt. This is again your high pressure belt. This is again your high pressure belt, and we have another high pressure belt here. So there are 4 high pressure belts. Now let's talk about the low pressure belts that are there. The low pressure belts, if we talk about, then we have the low pressure belt here at the equator. We have another low pressure belt here at the subpolar Arctic, and at the subpolar Antarctic. Okay, I think the colors are visible. If it's not visible, let's increase the thickness a little bit of it. I think you can understand it better now. Yeah, it is visible now. Okay, so these are the pressure belts that is there. Let's draw it here. This is your low pressure and this is your high pressure. Does this diagram look good enough? This is your low pressure and this is your high pressure, because nowadays often during these assistant professor exams and all these things you need to write for your mains exams also, isn't it? So aapko hamesha as a geography student you should be very prepared into making sure that you draw proper diagrams to whatever things you are trying to represent. So what happens, equator पे क्या है ना, on this equator the temperature is very high, क्योंकि बहुत ज़्यादा गर्मी है, तो यहाँ से air, whatever air is there, this air will uplift, ये ऊपर जाएगा air और ये यहाँ settle कर जाएगा. अब क्योंकि ये air यहाँ settle कर जा रहा है, there is high pressure, क्योंकि air वहाँ the amount of air is more, isn't it? Now since there is then similarly this, so what happens, this becomes your, this equator वाला ये क्या हो जाता है, this is because of a thermal reason, क्योंकि temperature की वजह से ये form हुआ है. Now but this high pressure, why is this formed? This low pressure was formed because of thermal reasons, but why is this high pressure formed? This high pressure is formed because of dynamic reasons. यहाँ पे temperature का कुछ ज़्यादा रोल नहीं है. This is because this air rose up from this part and it came and settled here, इसीलिए यहाँ पे high pressure form हो रहा है. So this is dynamic reason. Similarly, this low pressure is because of dynamic causes. This high pressure is again because of thermal causes. This high pressure is again because of dynamic causes. This low pressure is again because of this low pressure is again because of dynamic causes, and finally again this high pressure is because of the temperature causes. ठीक है, क्योंकि यहाँ पे ठंडा इतना ज़्यादा है, in the polar areas it is very cold, temperature is very low, that is why pressure is very high. ठीक है, and because of the rotation of the earth, because of the rotation of the earth, हम लोग अभी पढ़ेंगे क्योंकि Coriolis force, we'll be talking about Coriolis force very soon. Because of this Coriolis force, what happens when the earth spins, when the earth rotates, air from this place gets thrown out into these areas. air from this place gets thrown out in these areas, and because of this क्या है कि already तो यहाँ air जमा हुआ था because of this condensation, because there is very cold temperatures in that place, और अब क्या हुआ, यहां से भी एयर, क्योंकि अर्थ इतना स्पीड रोटेट कर रहा है तो वो हवा को फेंकते हुए जाता है दोनों तरफ, ठीक है। तो कोरियोलिस फोर्स इज वेरी हाई नियर द पोल्स, ठीक है। पोल्स की तरफ आप जितना जाते हैं उतना ज्यादा आपका कोरियोलिस फोर्स बढ़ते हुए जाता है, एंड बिकॉज ऑफ दिस कोरियोलिस फोर्स व्हाट हैपेंस, द एयर गेट्स थ्रोन आउट एंड इट सेटल्स एट द हाई प्रेशर of this region, assisting the high pressure and assisting the high pressure of this region also, लेकिन यहाँ से तो air आपका निकल गया है, and that is why it becomes a low pressure in this region. So these are your pressure belts that we talk about. Let's revise it once again. Let's look at it once again. So it's your equatorial low, the subtropical high, the subpolar low, and the polar highs, and their nature, the thermal and the dynamic and thermal, all these things we have discussed very beautifully in this diagram, and I hope that you will be remembering it nicely, and you can easily answer all the questions that come from it. Okay, so that's all about pressure belts. Understand? Now, as we saw that there are two different types, dynamic and thermal. So the thermal origin, iske bare mein there are two details a little bit: equatorial low, polar high, these are the thermal ones. Dynamic origin, the subpolar subtropical high and the subpolar low, these ones. Okay, you can see this diagram nicely, and to make sure that you have this diagram forever with you, make sure to join our Telegram channel. Okay, now अब देखिए, हमेशा ये ज़रूरी नहीं है, क्योंकि देखिए it's life, it's world, it's this earth, and the beauty about this earth is that there is so much diversity. And what does geography study? Geography studies this diversity that is there in the nature of all these things. क्योंकि ऐसा पैटर्न जो हम लोग जनरल पैटर्न एक बोल रहे हैं कि यहाँ पे हमेशा लो प्रेशर रहता है, यहाँ पे हमेशा हाई प्रेशर रहता है, it is not necessary, because there might be seasonal changes, there might be some other changes that might happen. For example, अगर आपके यहाँ पे जो एक हाई प्रेशर वाला रीजन है, if there is a mountain in this place, तो आप बहुत ज्यादा ऊपर जा रहे हैं वहां पे, है ना, यू आर गोइंग वेरी हाई इन दैट प्लेस, तो क्या होगा, प्रेशर डिक्रीज कर जाएगा, है ना। इन दिस पार्ट द प्रेशर माइट डिक्रीज ऑल्सो, इजंट इट, इन दिस माउंटेन वाला रीजन. So there are some anomalies, these are called as anomalies. What is it called? These are called anomalies. ये कुछ कुछ चीज हमें देखने को मिलता है जो फॉलो नहीं करता है इस जनरल पैटर्न को, and these are your examples in this place, isn't it? For example, आप देखिए यहाँ पे टिबेटियन लो, क्या बोल रहा है टिबेटियन लो, टिबेटियन प्लेटो कहाँ है सिचुएटेड, टिबेटियन प्लेटो सिचुएटेड इन दिस रीजन, टिबेटियन प्लेटो सिचुएटेड इन दिस रीजन, इंडिया सिचुएटेड इन दिस रीजन, इंडिया का जस्ट ऊपर में टिबेटियन प्लेटो है. लेकिन यहाँ पे हम लोग देख सकते हैं कि टिबेटियन प्लेटो में एक्चुअली हमें मिलता है क्या, वी गेट लो प्रेशर, वी गेट लो प्रेशर इन द टिबेटियन प्लेटो इन दिस पार्ट. ओके, इन द टिबेटियन प्लेटो वी गेट लो प्रेशर. So now if you look at it, so these are the anomalies that are happening, these are the changes that are there to the general pattern. Okay, so make sure you remember these anomalies. There is the Siberian high, the cause for it, and then the Canadian high, Azores high, Hawaiian high, Icelandic low, Aleutian low, Sahara low, Tibetan low, and the Colorado low. So let's draw a map for it first, and make sure as students of geography you should definitely know how to draw a world map. Okay, and it should happen in less than 30 seconds, because if that is not happening, then you should keep on practicing and make sure that your map comes out in just about 30 seconds. Okay, I'm not very practiced with this board right now, so it's taking me slightly less time, slightly more time. Otherwise I think I could have done a little bit more better. Okay, so this is your Australia, this is your Africa, Asia, Europe, North America, and South America. So what are the things that we are talking about? Okay, let's draw them out. Let's chalk them out. Okay, so first we have the Siberian high. We'll mark these as Siberian high. This is your one. Then we have the Canadian high. Okay, क्योंकि ये सब बहुत flat extensive land है, these are very vast lands, they are very cold. Okay, this is not oceanic area, and that is why they are very cold most of the time. तो भले ही यहाँ पे लो प्रेशर वाला सब पोलर वाला लो प्रेशर बेल्ट होना चाहिए, but you actually find the high pressure in this region. Okay, these are seasonal high pressure belts, which are, because in the winter season it gets so cold in these places that there persists a high pressure. Okay, then we have the Azores high, we have the Hawaiian High, okay, the Hawaiian High and the Azores High are all situated here. Then we have the Icelandic Low, we have the Icelandic Low, this is your Icelandic Low. Then we have your Aleutian Low, the Aleutian Islands are here, the Aleutian Low. Then we have the Sahara low pressure belt, the Sahara low pressure belt, although ये आपका tropical high pressure belt में आता है, लेकिन फिर भी there is so much heat in the Sahara desert that it forms a low pressure in that place. Then we have the Tibetan low and we also have the Colorado low. So these places are not actually following, because actually यहाँ पे क्या होना चाहिए ना, there should be high pressure in this region, but यहाँ पे हम लोग को देखने मिल रहा है low pressure, low pressure, low pressure again. Then there should be low pressure in this region, तो वहां हम लोग को देखने मिल रहा है high pressure के regions, ठीक है. So all these things you need to remember while, and they might ask you also that कि इसमें से कौन सा low pressure exhibit करता है, कौन सा high pressure exhibit करता है. So this is your Tibet, this is your Siberia, and this is your Sahara, okay. Then this is your Iceland, this is Aleutian, this is Aleutian, this is Canada, this is Colorado, and we have Hawaii, okay, Hawaii. So these things you need to understand, you need to remember, and make sure you have a proper idea about this whole table, okay, fine. Next, let's move on to the next part of our topic of discussion, that is the factors governing the wind movement. How is wind moving from one place to another place? Because see, the first factor that is there is that अगर यहाँ पे बहुत ज़्यादा, फॉर एग्जाम्पल यहाँ पे बहुत ज़्यादा एयर इज कंडेंस्ड एंड बहुत ज़्यादा एयर यहाँ जमा हुआ है, देयर इज अ हाई प्रेशर इन दिस प्लेस, लेकिन यहाँ पे क्या है ना कि देयर इज लेस एयर इन दिस प्लेस, दिस इज अ लो प्रेशर, ओके, दिस इज अ हाई प्रेशर बेल्ट, दिस इज अ लो प्रेशर बेल्ट. अब इस ग्रेडियंट को, इस डिफरेंस को हम लोग बोलते हैं एज द प्रेशर ग्रेडियंट फोर्स. वी कॉल इट एज द प्रेशर ग्रेडियंट फोर्स, ओके, वी कॉल दिस एज द प्रेशर ग्रेडियंट फोर्स. Now pressure gradient force का मतलब क्या है कि when the air is moving from high pressure to low pressure, तो air को कैसे move करना चाहिए? Air should just directly go from this high pressure to low pressure, क्योंकि high pressure वाले region में it is getting compressed and is getting pushed towards the low pressure region, because in that low pressure region there is less air, and उस vacant space को, उस खाली जगह को भरने के लिए यहाँ जो high pressure में इतना ज्यादा हवा भरा हुआ है, तो वो चीज को हम लोग move कर रहे हैं towards the low pressure, okay. So this is how the wind should move. These are the forces or the factors that govern the movement of the wind speed, कि wind कैसे move करेगा, wind का direction क्या होने वाला है. This is what we will try to understand. Now let's assume that this is in the northern hemisphere. This is in the northern hemisphere right now. Northern hemisphere में क्या होता है? Coriolis force. Coriolis force को समझने की कोशिश करते हैं. देखिए, Coriolis force is not a real force. First of all, Coriolis force is not a real force. Actually क्या है ना कि आप अगर मूव कर रहे हैं, लेकिन आपके नीचे तो अर्थ भी रोटेट कर रहा है, अर्थ इज ऑल्सो रोटेटिंग अलॉन्ग विद दैट, तो आप मे भी इधर जा रहे थे सीधा, लेकिन अर्थ तो रोटेट कर गया है ना, अर्थ रोटेट कर गया है, तो आपका लोकेशन क्या हो गया? नाउ यू कैन नॉट गो स्ट्रेट. आप अगर स्ट्रेट जाएंगे तो आप कोई और लोकेशन पे पहुंच जाएंगे, है ना. तो यू हैव टू टेक अ टर्न एंड यू हैव टू मूव दिस साइड फॉर एग्जांपल, ठीक है, यू हैव टू मूव दिस साइड फॉर एग्जांपल. नॉर्दर्न हेमिस्फीयर में हमें क्या करना पड़ता है? इन द नॉर्दर्न हेमिस्फीयर वी मूव टुवर्ड्स द राइट, ओके, वी मूव टुवर्ड्स द राइट. तो ये लो प्रेशर बेल्ट, क्योंकि अर्थ रोटेट कर रहा है, इट विल कम दिस साइड एंड यू विल हैव टू मूव टुवर्ड्स द राइट, ओके, यू हैव टू मूव टुवर्ड्स द राइट. सो दिस इज योर प्रेशर ग्रेडियंट फोर्स इन एक्शन, दैट इज कॉलिंग कि आप, हाँ, आप हाई प्रेशर में हैं, आप लो प्रेशर की तरफ आइए, लेकिन क्योंकि अर्थ रोटेट कर रहा है, कोरियोलिस फोर्स है, तो इसकी वजह से क्या हो रहा है? नॉर्दर्न हेमिस्फीयर में हमारा विंड को डिफ्लेक्ट होकर थोड़ा एक राइट डायरेक्शन लेना पड़ रहा है to go towards that low pressure region, क्योंकि वो जगह शिफ्ट हो गया, वो जगह, that place is changing its location, isn't it, because of the rotation of the earth. So it might have to take a new path. लेकिन बीच में एक और जन आ रहा है, that is friction, that is the frictional force, and because of this friction, क्योंकि there is एक घर्षण हो रहा है, एक friction हो रहा है, so if the wind was even trying to move this side, but it is not able to move because it is moving on a surface, एक surface है नीचे, है ना, and if that surface is there, the surface will try to create a friction, it will not let it take that direction towards the region that it was actually trying to go. So at the end what will happen is that the wind will neither go here, the wind will neither go here, the wind will actually go finally to this place. You understand? So this, the final one is the final direction of the wind. This is the final direction of the विंड, ठीक है। तो प्रेशर ग्रेडियंट फोर्स उसे बुला रहा था लो प्रेशर की तरफ। the Coriolis force was trying to rotate it towards the right hand side in the northern hemisphere. This is the Coriolis force in action, and finally this is the frictional force in action at the end कि आप उतना ज़्यादा रोटेट तो हम आपको नहीं करने देंगे बिकॉज देयर इज फ्रिक्शन, एक घर्षण हो रहा है। और आप अगर आप स्मूथली आप टर्न नहीं कर पा रहे हैं तो डेफिनेटली आप उस जगह तक नहीं पहुंच पाएंगे ना, आपको थोड़ा से रुक जाना पड़ेगा, कंप्लीट टर्न नहीं ले पाएंगे, ठीक है। लेकिन ये फ्रिक्शन क्या है? फ्रिक्शन इज बिकॉज ऑफ दी सरफेस, अर्थ सरफेस की वजह से फ्रिक्शन हो रहा है, घर्षण जो हो रहा है अर्थ सरफेस की वजह से हो रहा है। तो अगर आप अर्थ सरफेस से ऊपर की तरफ चले जाते हैं बहुत ज्यादा, तो फिर फ्रिक्शन का जो रोल है, स्पेशली फॉर एग्जाम्पल इन द रॉसबी वेव्स और इन द जेट स्ट्रीम्स दैट आर अपर ट्रोपोस्फेरिक एयर, ठीक है, उनमें फिर फ्रिक्शन काम नहीं करता है। फ्रिक्शन is not a factor that is included in the so it is not a factor for upper atmospheric winds. Okay, it is not a factor for the upper atmospheric winds. So these are the forces governing the wind movement, and finally we have this pressure belt का जो हम लोग डिस्कशन किए थे यहाँ पे, ठीक है, प्रेशर बेल्ट का जो हम लोग डिस्कशन किए थे। लेट्स ड्रॉ इट अगेन लाइक दिस। लेट्स जस्ट ड्रॉ द नॉर्दर्न हेमिस्फीयर, ठीक है, लेट्स जस्ट ड्रॉ द नॉर्दर्न हेमिस्फीयर। सदर्न हेमिस्फीयर में फिर से वही सेम बात होने वाला है, ठीक है। सो लेट्स जस्ट ड्रॉ द नॉर्दर्न हेमिस्फीयर। व्हाट इज हैपनिंग हियर इज दैट आई थिंक द लाइव इज वर्किंग फाइन इनफ। yes yeah, it is good enough. Okay, so what is happening in this place is that this is your low pressure belt. Let's mark it again. This is your low pressure belt. Then this is your again high pressure belt that is there. This is your high pressure belt. Then again we have a low pressure belt, and finally again we have a high pressure belt. Okay, this is your subpolar, this is your equatorial low. Let's get started again properly. This is your equatorial low. This is your subtropical high pressure belt. This is your subpolar low pressure belt, and we have the polar high pressure belt. Okay, so these are the four belts that are there. अब क्योंकि यहाँ क्या है, यहाँ पे है आपका लो प्रेशर, यहाँ है आपका हाई प्रेशर, देयर इज अगेन हाई प्रेशर हियर, then there is low pressure again here. Okay, so if the wind needs to move, the wind will move from high pressure to low pressure, isn't it? The wind will move from high pressure to low pressure. लेकिन आप इस चीज को नोटिस कीजिए कि because of the factors that we studied right now, the wind will not come like this. It will take a turn, it will take a right turn. देखिए इस लोकेशन में अगर आप खड़े होकर अगर आप नोटिस कीजिएगा तो इट इज टेकिंग अ राइट टर्न टुवर्ड्स दी low pressure belt. Okay, so these kind of winds are formed in the belt between the subtropical high and the equatorial low. Then again from high pressure to low pressure, it will take a right turn. It will take a right turn this side because this is the northern hemisphere. The Coriolis force is in action. And the friction force are in action. And the pressure gradient force is in action. And these are all impacting the direction of the wind that we are able to see. Similarly, again, from the polar areas, from the high pressure to low pressure, the winds will come because winds move from high pressure to low pressure, and while moving the Coriolis force is trying to turn them towards the right. Because of the Coriolis force, it is turning towards the right, but the frictional force is not letting it turn completely towards the right. थोड़ा सा एक deviation उसका रख दे रहा है, and वो complete right turn भी नहीं ले पा रहा है, ठीक है। So finally we get this pattern on the surface of the earth, and this coincides with your pressure belts that is there. Now what are these winds called? So these winds are known as the trade winds. Then these winds are known as the westerlies. Why westerlies? Because they are coming, for example, let's take this is north, east, west, south. Okay, so they are coming from this western side, so they are called as the westerlies. Similarly, these are called as the polar easterlies. Okay, so this is your wind pattern that is there, the trade winds, westerlies and polar easterlies. And there are a few associated terms along with that, and that is, for example, doldrums, the horse latitudes, and the polar front. Because in the equatorial areas, uh, in this part, the winds from this side, यहाँ से भी winds आएंगे आपके, यहाँ से भी winds आएंगे इस तरफ से southern hemisphere से, and see they are taking a left turn in the southern hemisphere, isn't it? They are taking a left turn in the southern hemisphere. Now when these winds come, they rise up, okay? और यहाँ पे बहुत ज़्यादा wind activity नहीं हो रहा है, the air is completely rising up, the winds are not moving on the surface very much, isn't it? Because of that there are very calm conditions, and यहाँ पे ships and all move नहीं कर पाते हैं. फिर similar kind of situation होता है आपका इस high pressure belt में भी. These are called as the horse latitude in this place that we can see here. Okay, the horse latitudes, the calm and dry. Okay, the doldrums, there is calm and weak winds are there. And finally we have the polar winds, polar front winds that are there. Okay, the polar front winds that are there. So these are some anomalies that happen in the final situation of the general pattern of the wind distribution that we are seeing in here. Okay, so that's all in today's class, and I think we were able to understand very nicely. What were we able to understand today? We were able to understand about the atmospheric circulation cells, that is the Hadley, Ferrel, and the polar cells. Always revise when you study, okay? The pressure vertical surface, so on the surface it is 1013.25 millibars, and as we go high it reduces. And then the thermal and the dynamic pressure belts that were there, the equatorial low, the subtropical high, the subpolar low, the polar high pressure belts, all these things we were able to understand. Then the seasonal pressure systems that are there, which exist only in a few seasons. For example, your Tibetan low, the Colorado low, the Aleutian high, the Aleutian low, the Siberian high, and all these anomalies that we were able to see. Then we also talked about the pressure gradient force, the Coriolis force, and friction, how they impact the origin, how they impact the origination of a wind and also its direction, okay, how it impacts the origination of the wind and also its direction. And finally the global wind system that includes your trade winds, the westerlies, and the polar easterlies that were there. So all these things have been covered in proper detail. Make sure to definitely follow us on our Telegram channel for the proper notes of this class and for proper continued updates. And here at NetwalaBhaiya, we will study with emotions, and we will connect to the subject better, and will make sure that your UGC NET GRF journey becomes easy and achievable. Okay, so thank you so much. Thank you very much for coming to this class. Make sure to share this. It's all absolutely for free. We are doing it because we want that others come into the field of research, do their PhD, and get that GRF that they deserve. Okay, so thank you very much. Thank you once again. That's all from my side. Signing off.